The sine rule. Some of you might have learned it ages ago in school. Some of you might not have learnt it more properly until more recently. But whenever you learnt it, you might be interested to know, what is the proof of it? Well, I've got you covered in today's video. And in case you need a reminder of what the sine rule actually is, it's this idea where you can take any triangle you like in the world, label the three angles, capital A, capital B, and capital C. Then you're going to label each of the three sides with the same letters used for the angles, but the side you label with the same letter is the side that's opposite each of those angles, and you're going to be using the lowercase letters for the sides, so you know what's a side, what's an angle when you look at the labels. And therefore you can see what the result of that is on the screen right now. If you've labelled the triangle in that way, though, you can then therefore say this must be true. A over sine of A must equal B over sine of B must equal C over sine C. That's the sine rule. But what's the proof? Well, before we get into the proof, I must warn you. Yes, you don't need to know the proof for the exam. You need to know the formula for an exam, but you don't need to know the proof. We're doing the proof just for fun. And in fact, if you find this sort of stuff fun, you should consider liking the video and subscribing, because we've got a nice little small channel here, which is actually a good thing because it means I don't feel under any pressure to do videos for views. All the stuff I've got here doesn't involve clickbait titles, clickbait thumbnails. What you see is what you get, which is maths. So if you like that sort of stuff, if you like this sort of stuff, subscribe and join the group we've got growing here, because I've got plenty more videos coming up in the future doing this sort of thing. So there you go. But anyway, what do we need to know in order to be able to do today's proof? You need to know the diagram we just showed you a few moments ago, because that's important for keeping track of what side is labelled what when we're doing the maths we're doing. And then also, you need to be able to do right angle triangle trigonometry. That's the classic soccer TOA stuff, if you're familiar with that acronym. And there you go. That's what you need to do in order to be able to do today's proof. So it really isn't too bad, hopefully. Therefore, you should be able to follow on with what we're doing in this video. So with all that said, let's get started. So the first thing I'm going to do is going to draw a triangle, label the sides as you can see, and I've drawn it so that the base is nice and horizontal. And the reason I've done that is because I'm now going to draw an extra line from the top of the triangle, the vertex or corner at the top, and draw it straight down all the way until it hits the base. I'm also going to have drawn it so that that line is at a right angle to the base, and then I'm going to label it. You can label it whatever you like. I've decided to label it H. No reason, I just have. Cool. Nice. The reason we've done that is it meant we now have effectively two right angle triangles in one. For instance, we've got a right angle triangle there on the right, and the reason we're doing that is because it means we can now involve basic right angle triangle trigonometry. You might remember that if we've got a right angle triangle, sine of the angle is equal to the opposite side divided by the hypotenuse. You can rearrange that to say that the hypotenuse times by the sine of the angle equals the opposite. And that's great because for our right angle triangle, of course, H is opposite the angle C, so H is the opposite side. The B is opposite where the right angle is, so that must be the hypotenuse of our triangle. So therefore, we can say that H is equal to B times by sine of the angle C. Nice. We've got a fact, an expression for H. But why did I have to find it using that method? Why did I have to use the right angle triangle that's on the right? Couldn't I have used the one on the left? Well, you could have, but if you did, you'll end up with a slightly different expression. Let's take a look. If we use that left-hand triangle, now the side H is opposite the angle B, so we can still call it the opposite, but now the hypotenuse is different. The hypotenuse is going to be the side labelled C. So therefore, if we do right angle trigonometry with that, we can say that H is equal to C lots of sine of B. So we've ended up with a different expression. But both of these expressions both must be equal to H, so they therefore must be equal to each other. So we've formed an equation. And we can rearrange that equation because we could divide both sides by sine of C. We could divide both sides of the equation by sine of B. And what do you know? You end up with B over sine of B equals C over sine C. Technically not done yet because we haven't involved A at all yet, and until we've involved A as well, we haven't got the full sine rule. So what we got to do is go back to our triangle again and rotate it so a different side is at the bottom. So doing that, except the labels seem completely the wrong way up. So if I adjust that so the labels are now the correct way up, we end up with this. And then once we've done that, we can basically repeat the process we were doing before. So you're welcome to pause the video and have a go at doing this stuff yourself and then seeing whether you get the same as me. But if you'd rather watch me do it, well, we're again going to draw a line from the top to the bottom that's at a right angle. I'm going to label it K this time. Use the right angle triangle on the right to do some trigonometry. That will tell you that K is equal to A lots of sine B. We can then use the triangle on the left, do triangle trigonometry again to get the fact that K is equal to B of sine of A. And then these two things must be equal to each other. So A sine B equals B of sine A. Then we can do some division, divide by sine of B, divide by sine of A, and boosh, A over sine of A has got to equal B over sine of B. And if you combine that with the fact we said earlier, which was B over sine B equals C over sine of C, as both of these things involve B over sine of B, everything must be all equal to each other. So we can all smash it together in one big equation to get the sine rule. Yes, that is the proof behind the sine rule. A little extra bonus fact though. Have you ever tried applying the sine rule to a right-angled triangle? Well, if you do, well, for this particular case, I'm not going to care about A for the purposes of what I'm about to demonstrate, so let's get rid of all that stuff. We could start to point out that the longest side of the triangle was B in this case, so let's relabel it as the hypotenuse. We could label the angle C as theta, as the side C is opposite where theta is. That could be labeled as the side called the opposite. And also the angle B is where a right angle is. So that means we know it's 90 degrees. If you whack all that stuff into the sine rule, then you end up with what we've got on the screen right now. But that's interesting because sine of 90 degrees, did you know, is equal to 1. So therefore, you get hypotenuse has got to equal opposite over sine of theta, which we can rearrange because you could multiply both sides by sine of theta, divide both sides by the hypotenuse, and you end up with sine of theta equals opposite over hypotenuse. Yeah, there you go, another cool fact that's appeared out of this. Now that's not a proof of sine theta equaling opposite over hypotenuse because we actually had to use that fact to prove the sine rule, so we can't use the sine rule to then prove that fact, otherwise it's a circular argument. But it is neat because it does at least show that this right angle triangle trigonometry stuff is just a special case of the sine rule for the bit of trigonometry involving sine. So there you go, that's pretty neat in case you hadn't seen that before, and therefore we are done today. That's some stuff involving the sine rule, and you should consider looking at some other videos. I've got a link to some of them on the screen right now, another video in the Prove It series. We're basically trying to prove everything in the Maths A level eventually, so if that interests you, I've got loads of videos doing that stuff. Goodbye.